Okay, so let's start Mongo, right? And it's gonna go and connect to the database, to the mongodb that we had already gotten started. Right now it's connected, and you can notice that you have a prompt to be able to communicate with it. Let's make this. There we go. All right. We can make commands such as ask for a list of all the databases. For instance, what databases are being stored there. You can say just show DBs. And right now we have just a few of these. We have an admin database. We have a F360, project, speak app, test. So these are the databases that my server knows about. And you can change from one database to the other by using the use command, use, and then you can go into test. It tells you switch to test, or you can use speak app. It says it's switched to speak app. Okay? All right. So for our purposes, we're going to create a brand new one, and we're going to say use CS 5610. Okay, so I just created a new database, CS 5610, for this course. All right. All right. So once you are in a database, you can start asking, okay, well, what tables are there? Well, we don't call them tables in Mongo, right? We call them collections, right? Think of them as arrays, right, or sets, right, or collections, right? A collection of documents. Right? We don't say a table of rows. We say these are collections of objects, right? And we can say, well, show me all the collections, and there are none yet. There are no collections. Because it's a brand new database, there's no data in it. So we can start creating data into these databases by using commands that all start with DB, database, DB. And it's an object-oriented syntax where DB is an object that has many functions associated with it, right? So you can say DB dot, and then you can access a whole bunch of functionality off of that one object, right? DB dot, and then one of the things that you can do here is that tell it what collection do you want to interact with, but there are no collections, right? So here we're going to try and add a collection here. We can say db.user. Now there is no user collection, right? There is no information about any user. So what it's going to do is that if it doesn't exist, if the collection doesn't exist, it will create it for you, brand new. Right? So there's no specific command to create a collection. Right? Unlike in SQL, you would have to create a table. Explicitly you would have to say create table, the name of the table, right? And then specify all the fields in that table. Yes? Here there's no such thing. In fact, there is no schema. Right? Whereas in SQL, it's very crucial that you create a schema before you do anything with any data. Right? That you have to specify the structure of the data you want to store. Right? Here there's no such thing. In SQL, you have to say create a table that has called users, right? I want the fields in there to be called first name, last name, email, password, and so on and so forth. Yes? Right? And then once you create the table, you can then start inserting into the table, correct? But you can't insert until you actually create the table. Here, there's no such thing. There is no schema. Right? MongoDB doesn't have the notion of a schema. Right? Those of you who have done relational databases, you might be cringing. It says, what do you mean there's no schema? Okay. Again, we're not storing structured data. We're storing objects. Right? The objects might have a schema, okay, but it is not going to be the database's responsibility for that schema. It is whoever's storing these objects' responsibility. Right? In our case, it's our application. Our application is going to be responsible for the schema of our objects. Okay? Our classes, when we created the classes up in, when we in TypeScript, we are following a schema, right? Our users have usernames, passwords, first name, last names, and they're all strings, right? The date of birth are dates, salaries are numbers, and whatnot. Yes? So that's where we're maintaining the schema, up in our application. It's an application-specific schema, not in the database. Right? So we're delegating the responsibility of the schema, we're delegating it to the application, not to the database. Right? When using relational databases, you kind of have to maintain two schemas. Right? The schema when you're going to store in the database, and then another schema at the application level. And not necessarily they're one-to-one. Right? Usually in Java you might have you might maintain your classes that use polymorphism and use inheritance, right? But certainly SQL doesn't support any of that, right? So at some point you're going to have to do a conversion between the schema in Java, right, and then the schema in the relational database, correct? So you have to maintain two schemas: the application schema and the database schema. Here we only have to maintain the application schema, right? The database just stores whatever you tell it to, okay, which hopefully is already following some good practice of how the data was divvied up. Anyway, so we want to store information about users. So I'm going to say db.user, and then I like to insert data in there. Okay. If I want to insert data into a collection called user, I would use the function insert with a parentheses that I can pass in the object that I want to store. Okay? And the format of that object, as I mentioned earlier, is JSON format. Right? Objects in JavaScript, objects are just plain old curly brackets with name value pairs. That's all an object is in JavaScript, right? So here we can provide things such as username, right, Alice, okay, and several other ones. Maybe first name Alice, last name Wonderland. Okay, and that's it, right? That is going to insert data into a collection called user, and it says that it was successful. One document was inserted. Right? Once it's inserted, if I ask again to show me the collections, it tells me that indeed now there is one collection, the collection that was just created. Right? Notice that there was no explicit creation of the user collection, right? It was created on the first insert. Everybody okay? Yes. The keys. So we didn't specifically give it a key, right? But if we retrieve the object, you'll notice that Mongo created a key for me, right? So very much like in relational databases, we might ask the database to keep track of its own keys. Right, we say that it's either auto-incremented, or in Oracle we might say that it comes from some kind of sequence. Yeah, we delegate the key generation, the primary key generation, to the database. Right, so same thing here. Let's retrieve this one record that we just created, right, and we'll see what I mean. So to retrieve the data that we just inserted, we can say again db.user. We're still manipulating the user collection, and we can find. So find is the equivalent in SQL of doing a select, right? Of retrieving data back from the database. So there's .find. This is really the only one find method you need. There's a couple more, right? But they all get converted into some form of this .find function. If I do an enter, it lists all the documents that are stored in this collection. Right? In this case, we just have Alice stored in there. You'll notice that it has all the fields that I used, right? Username, first name, last name. But notice that there's an additional field in there that says _ID. See that? Right? And it has a funny data type that is object ID. It's an internal representation of its primary key, right? That it uses internally to index this document to be able to find it quickly later on. Right? But it has its own representation of what a primary key is. Right? You can, if you want, override the value of underscore ID. Maybe you want to use maybe a social security number, or you want to use some student ID or some other known primary key, right? You could do that, but it's more convenient just to let it handle the primary key itself, right? It's guaranteed to be unique within that collection, right? To be unique, all right? Okay. Sometimes if these fields are way too many, in this case we only have 3 fields: username, first name, and last name. We can tag along additional functions that can convert or that can transform the data that comes back from the database, right? So for instance, we can say that I wanted to see it in a pretty format. Right? Pretty format will pretty the format so that it's a little bit more readable, right? In this case, it'll put every field and value in separate lines, in separate lines. Okay, right. So let's insert yet another one. So let's insert now maybe Bob. Okay, I've inserted 1. If you do a find again, notice that it comes back with two records. That the Alice and Bob. Right? And if you do a pretty, again it'll sorry. Oop! Did I just insert another one? Oh, I didn't mean to do that. We're gonna do a find pretty, and notice that I have 3 records. Right? One Alice and 2 Bob Marleys. Okay. Even all right. Everybody okay? Because I inserted again by mistake. All right, so we can remove, just like we can insert. We can also remove. We can say remove, and we can provide a where clause. Typically in SQL. Oh, delete. Let's go back to delete. Oh, I'm sorry. Yeah, it is remove. DB collections. Okay, so typically, if you do a remove and you don't give any filters on what is it that you want to remove, in SQL it would remove all the records. It's like doing a delete from a table and you don't give it a where clause, right? It interprets that as you want to remove all the records. Well, what a dumb way to interpret that. Here, it doesn't remove anything, right? It just gives you there's an error. Typically, you want to give it a query. You want to give it a where clause saying that I want to remove the following records, the records that match the following criteria. Right? I don't want to remove all of them. If I give it like this, a curly bracket and empty, that's as if saying remove all the records and there is no criteria, right? So careful, that will remove all the records, right? With just the curly brackets, right? Empty curly brackets. What you want to do here is provide some criteria. Perhaps you could say that only the ones that match with the username Bob, okay, those are the records that I want to remove. Okay, if I do that, it comes back saying that I removed 2 records. Well, we don't call them records, we call them documents, 2 documents, right? Because I had inadvertently inserted 2 Bobs, yes? Okay. If I ask for the list of users again, notice that I only have Alice, right? The 2 Bobs were removed, okay? So let me add Bob there again, okay? And ask for both. There they are. Both of them are there, Alice and Bob. Now, our find method, I can be a little more specific. In the find method, I can also, right, if I don't provide any predicates here in the parentheses, it'll just return all the records. Right? But I can be a little more specific and provide a filter saying which records do I want, right? And I can specify here the what things that I want it to match. So I could say that I only want the ones that match with my username equal to Alice. See that? Right? If I do that, then it only returns Alice. Right? It doesn't return Bob. Make sense? Right? So you can provide the arguments, the filter of what is that you want in there. And there's pretty sophisticated filtering mechanism, just like you would expect, like in SQL, right? You can do greater than, less than, equal to, ands, ors, right? You can do Boolean expressions that it's equal to this but not equal to that. So it's the full spectrum of logical operators, right, that you would expect from any data storage solution. Okay, they're all there. All right, so we looked at find, that allows you to retrieve records, or one or all of them. We looked at delete. Okay, we looked at create, right, being able to insert a new record. There's also update. You can also update a document. So for instance, here's Alice, and let's say I want to change Alice's first name. Right? I can say db.user.update, and update takes two arguments. The first argument will tell me which document you want to update, and the second argument will tell me what is it that you want to change. Okay? So the first one tells me, let's change the record whose username is Alice. Okay? And the second argument, right, is another JSON object where I can specify what do I want to change. Right? So here I can say first name colon Alicia. Now this is going to what it's going to do, right? It's going to replace the entire object with this new object, okay, which is probably not what we want, right? So if I do that, which I'm not going to do, right? It's going to replace everything. So we're no longer going to have our username. We're no longer going to have our last name. We're just going to have our first name. Yes? All right, so I'm not going to do that. Instead, there's a more sophisticated version of this that you can specify exactly which field you want to modify. Right? And that is by providing a set command. Right? The set, notice that it has a $sign in front of it. Okay? Mongo declares many different operators, right? The AND operator, the NOT operator, the OR operator for doing logical Boolean operations. There's also the IN operator, if you want to look for things in an array, right? It also has the set operator. They all start with $sign, to remind you that this is not a field, right? It's not an attribute. It's not a value. Okay, this is a system declared operator. Okay? And it's the first. It's in the property place of a JSON object. Okay, notice that here it opens the curly bracket right here. Right, then $sign set colon. Right, just like a JSON object, right? You have that's the property. The property name is set, and then the value of that property is the field that you want to change. I want to change the first name, so it's a JSON object, and then the new value, Alicia. And I do an enter, and it comes back saying, yep, there was one document that matched your criteria, and yep, I modified one of those documents. Okay? If we do a find again, we see that the first name has been modified, Alicia. Everybody okay? Yes? So these are all the basic operations, right? Being able to insert, be able to retrieve, being able to update, being able to delete. Right? Those are the only 4 real operations that we need. Okay. One more thing that I wanted to point out is that if you retrieve all the documents, we see that we have Alice and Bob there, right, with their property names, username, first name, and last name. So let's add one more, right, to just point out something here. Let's create yet another one. Okay. Let's see. We'll do a DB. See if you can spot what I'm doing. So DB user insert, and I'm going to create username Charlie, right? And I'm going to give it their Charlie's name, so it's be Charlie and Garcia. Okay. So anybody see anything wrong with that? So the fields don't match the fields that we used in previous objects that we've inserted, right? And now this would be a not allowed, right, in a relational database. Right? The fields typically are very well defined. Right? There's a very well defined number of fields, and their data types are strongly typed. Right? No such thing in NoSQL. Right? There is no schema. We never created a schema. Okay, so the data that's being inserted, right, or updated, okay, is never verified against any schema, whether it's correct or not correct. Okay, it is not the responsibilities of the database to do any of this. Right? So if we ask for the list of users, we notice that all three records are just fine. Okay, we have 2 of them that the schemas match, and we have a 3rd that does not match. Okay, but that's only our construction. That is only our prejudice, right? That we say that it doesn't belong, right? Only because we come with the prejudice of having worked with relational databases that are very strongly typed, or have a very focus on schema. Okay, we don't have that here. It is perfectly fine to mix and match objects. Not that you would do that. It's not something that you would do deliberately. Okay, but nevertheless, if tomorrow or a year from now the schema needs to change because there was a field that we forgot to put in or whatever, right? No big deal. Right? As long as the application can handle it, at upstream at your application level, MongoDB will be able to handle it. Right? As long as you can deal with some inconsistencies and how you're going to resolve those, right? That's fine. Mongo can extend. Its schema is malleable, right? It's plastic. It has a plastic schema. It doesn't have a fixed schema. Right? Again, not that you would do actually something like that. Right? If things are going to be inside of the same collection, typically you want all the documents in that collection to have the same schema. Make sense? Another thing is that the names that I choose for my collections are always singular, right? User, and it's just me. I don't like to use plurals, since at least in English and in many languages, plurals are not consistent, and some words don't have plural, and it just makes it harder to know what did you call it. So I just rather use the singular. Right. All right, great. So here we go. We know how to use Mongo and to interact with the database directly from the command line. Right. More interesting is to be able to interact with the database programmatically. Right. To be able to program and create an application that interacts with the database, that fetches data back and forth from the server, right, from an application. Let's do that next.